Hi. Yeah, it's nice to see you all. It's a very cozy evening. I hope you enjoyed so far. And yeah, the talk number 0, as it was said, and it's called Scaling Prometheus the Hard Way. It's kind of clickbaitish, but I hope you will like it anyway. So yeah, about me, I'm Nikolai, or Nick. I'm a platform engineer at Trade Republic. I'm working in a team that is focusing on building observability tools to make them scalable, user-friendly, and stable, the most important one. And yeah, one of my hobbies is singing in a indie pop choir Berlin. So you can see that I love being on stage, and yeah, I also love traveling and exploring a lot of technologies. Cool, so let's go to the agenda. So first I would like to tell you about the history of metrics setup in Trade Republic, and like what kind of evolution it had. So, and next we will quickly cover why and how to scale Prometheus. Then our current challenges, what is blocking us like from scaling right away. And the last part, just closing remarks, covering everything I told you. So yeah, the first part is history of metrics setup at Trade Republic. I think like this is what we had 4 years ago, I think so. So basically, yeah, the basic setup, which is Prometheus, pointing to scraping all the targets, pointing to our alert manager, sending all the alerts to alert manager, and Grafana just for building the dashboards and viewing everything, all the metrics for the engineers. And the next, so after some time, we decided to switch to Datadog. So it is an amazing observability solution with lots of stuff. So we started sending traces, we started sending logs, metrics as well, and it was pretty cool. But after some time, our management saw the bill that we paid, and we decided that, damn it, let's switch to something else. So yeah, one of the principles at Trade Republic is every day is day one. So yeah, we decided to like throw away Datadog and replace it with a Mimir, which is a solution by Grafana. And yeah, so we have it self-hosted, we have it centralized, so we send all samples from all Prometheus to Mimir. And yeah, it is going well so far, but as you can notice, so our Prometheus at our core hasn't changed up since like the very beginning. And yeah, let's zoom in. So currently, our Prometheus scrapes all the targets inside our Kubernetes clusters. So we have one cluster per environment, one cluster for production, and inside this production cluster, we scrape everything. We evaluate all deployed Prometheus rules in the Kubernetes, which is Prometheus rule resources provided by a Prometheus operator. And also the same instance responsible for all alerts. So yeah, basically it sends them to alert manager and so on. And the last part is that it's also responsible for sending all samples to a remote storage. In our case, it is Mimir. And yeah, and we have a highly available setup with one replica, which I will cover a bit later. What we noticed over the past 6 months, so Toby already mentioned that the company is growing very fast. There are a lot of new launches, new services are deployed, and we see that we have drastic increase in our load to the Prometheus. And so first thing is to check that we check this active time series. You can check it with the same query. Maybe you don't need an average if you have only one instance. And yeah, you can see it's doubled over 6 months. And we have some weird spikes here. It's when we had small incidents with the cardinality explosions that I will also cover a bit later. And another thing that contributes to the load to Prometheus is samples, how many samples per second you scrape. It kind of depends on an active time series, but it also depends on the scrape intervals that you specify in service monitors. So you can also check it with this query, and you see we had these spikes for cardinality explosions, but overall it's growing. It has grown 2 times. Yeah, so the same for resources. We had some new launches, as I said. We had new recording rules, new alerting rules, and the resource usage almost doubled. Yeah, for CPU and for memory as well. One of the interesting things that you can check, so basically Prometheus is a Golang application, and you can fetch a profile from it, and you can dive into this profile and build a flame graph. And you can check, like in your case, where your Prometheus spent the most time of the CPU. And in our case, so it's spending the biggest part on rule evaluations, so it's 37%, and yes, you can see like where it spends other parts of CPU. And yeah, in our case, so we have a lot of alerting rules, a lot of recording rules. We need like to spend a lot of time evaluating them. Cool. So yeah, the question why and how to scale. But before even starting thinking about it, make sure that you have all the safeguards to protect your Prometheus for the spike loads that we had, for example, when you had a cardinality explosion. And for example, one of such things that you can set in your Prometheus is cardinality limits. So yeah, what we had is we had a service, and it pushed such kind of change into the production, and you see it's, so they probably wanted to publish this state value to the one of the labels, but unfortunately they put request ID, and this leads to lots of unique time series being exposed by a target, and the more time series you have, more memory your Prometheus utilize, and the more CPU usage for, I don't know, for aggregating everything for alerts and sending also samples to the remote write. But you can avoid, in such cases, such scenarios if you set, for example, sample limit in your Prometheus configuration, and this will help you to limit the amount of time series exposed by one target, and if this limit is exceeded, the whole scrape will fail. So you also need to alert on the metric that I put below, and alert or monitor, whatever, but yeah, it's very important. Cool. So why scaling? Why do you need to think about it? So first of all, vertical scaling, it's not only for Prometheus, but overall it's very limited, it's very costly, and yeah, it's not very convenient to have to like indefinitely scale vertically. Second of all, Prometheus TSDB is not very optimal for long-term storage, so it uses a lot of disks. The querying is not so fast when you need to query very big amounts of data. So yeah, this is also a challenge. And the last part is, so you have one Prometheus for everything. It is basically a single point of failure. So if Prometheus is down, you don't have any metrics, you don't have any alerts. So you need to kind of somehow scale it. And yeah, the first step that you can make is just add a replica. So basically the same Prometheus instance that will scrape everything that original Prometheus does, and basically have 2 identical sets of data. And in case, like, for example, you need to update a node in the Kubernetes, or you need to update the Prometheus itself, or something happens and you lose one replica, you still have another one and that still contains data you need, and it is able to alert. So the next step would be so we have 2 replicas, but you want to offload the data to some dedicated storage for long-term usage, and you want to like query huge amounts of data. In such case, you probably want to remote write or do something else and send your data to such solutions like Victoria Metrics, Thanos, or Mimir. But if you still have two replicas, you need to make sure that in your long-term solution you have some kind of deduplication logic. So for example, in Mimir we set HA tracker, so basically it tracks by an instance label of the unique replica, and it selects one replica to as a leader and store only samples sent by this replica. So what next? Now we want to split it horizontally, to shard it horizontally somehow, and the first thing that comes into mind to have multiple different Prometheuses that are responsible for scraping specific part of your metrics. For example, you can split by environment, or you can have more granular logical split, and you can split by namespace and, I don't know, deployment. But in this case, you will have to manage more Prometheuses. This is quite challenging, probably worth another talk. But yeah, it's not impossible. And so, yeah, what is current state at Trade Republic? As I mentioned, we have a HA setup, so we have two replicas. We decided that this is enough for us. We have Mimir as a long-term storage, so engineers only use it for querying. It's not used for alerting yet. And we have Prometheus per environment, but we don't have more granular split yet. What's blocking us? So first challenge that we faced is monolithic service monitors. So some time ago, we decided to provide one service monitor for all production services. So basically, they only need to set one label on their servers to be, and this service monitor will select this service based on that metric. So service monitor is a custom resource provided by Prometheus operator. So you apply this resource in Kubernetes, and Prometheus operator will automatically generate the configuration for Prometheus to discover all your targets inside Kubernetes. And yeah, so basically, what is the problem here is that you can't have like Prometheus per namespace that will use the same service monitor, and it will only scrape the targets from the same namespace. You need to split this service monitor somehow. Yeah, what kind of options we have? Refactor this service monitor and split into multiple service monitors, like 100 plus, which sounds like a lot of work because we need to synchronize with the engineers to make a lot of pull requests and so on. The second option is to provide another sharding approach. So for example, Prometheus operator provides automatic sharding, and this kind of sounds more attractive to us. So yeah, we decided to go with a sharding provided by Prometheus operator. So what does it mean? So in Prometheus custom resource, so provided also by Prometheus operator, you can specify the amount of shards, and in the background, Prometheus operator will generate a special configuration that will help you to spread all your targets between multiple Prometheus instances. What kind of magic is that? But it's very simple, so you can do it yourself even without Prometheus operator. What you need is to take a hash from the, for example, address, from some kind of unique label, take a modulus from this hash, and you need to keep the targets that only have specific like shard number. So here we have 0, but it can also be 1, 2, 3, or 4. So yeah, this way, when you can have multiple, I don't know, Prometheus instances that will only scrape specific sets of targets defined by these filters. Cool. Another challenge that we faced is global alert evaluation. So what I mean is that currently we evaluate, so previously we evaluated everything against existing data in Prometheus, and this, if we want to split it, with the help of Prometheus automatic sharding, or with the help of, I don't know, some kind of logical split. For example, we have such query, but the data is present only on one of the shards. And this alert will be evaluated in both shards, and in one shard it will be false positive. We want to avoid it. So what options do we have here? So first is maybe isolate all alert rules to have specific Prometheus alerts for specific shards. But with if you use Prometheus operator that dynamically shards all your targets, this is impossible. So another option would be to offload all the evaluations from Prometheus to a centralized place. And yeah, we already have it. We have Mimir, but we don't use it yet for alerts. Yeah, it was like difficult decisions, but we decided to go with that. Mimir provides a special ruler component, which does almost the same. You can apply the same alert rules to Mimir. But the problem is that when you send samples from Prometheus to Mimir, you introduce additional delay, like latency. It can be, a lot of things can contribute to this delay. So latency or batch time out on a remote write. And so your write path becomes very, very critical. Previously, for example, if we had, like, I don't know, a lag of 10 seconds, it was fine because eventually metrics will reach Mimir. It will be ingested. But now, if we have a delay bigger than alert evaluation interval in Mimir, this is a problem for us. So probably you need to check the metrics on your dedicated storage, but also you can check some metrics in Prometheus itself. For example, with such metrics in the bottom, you can check what is the lag, what is the current lag, like what kind of delay you send your metrics to the remote storage. Yeah, but so we have all our Prometheus rules deployed in Kubernetes as a Prometheus rule resource, and they are all in code. And but Mimir doesn't have anything that can help us to use the same Prometheus rules to deploy them to the Mimir ruler. What we need is something that will synchronize existing Prometheus rules, but also adds the labels that are added when we remote write to Mimir. So, for example, we add environment variable, and we also need to apply the same filter for the rules that we deploy to Mimir. If you don't have it, all alert rules will be false positive. So we found a solution. So first we thought maybe we can build something ourselves, but the solution in our case was Grafana Alloy. So this is an observability agent provided by Grafana. It is also considered as an OpenTelemetry collector distribution, and it also has a lot of interesting components. And in our case, it was a Mimir component that can help us to synchronize the Prometheus rules with the Mimir ruler. So it not only syncs, but it can also inject labels in the queries that are applied to the rules. And yeah, this is like what helped us. We decided to go this way, and yeah, in future maybe we will make some kind of continuous deployment with a dedicated way to apply the rules. For example, some kind of shorter configuration file, alert YAML, something like this. Yeah, so this was our journey. I'm approaching the end of my talk, and let's recap everything. So basically, we had a very quick growth of our business. We need to scale Prometheus somehow, and we decided we faced some challenges. We decided to overcome them with using some logical splitting, sharding provided by Prometheus operator, and also some tricks with, for example, Grafana Alloy to synchronize the rules with the Mimir centralized ruler, centralized global rule evaluation solution. The journey is pretty interesting. I think there will be more in future, and I hope you discovered something interesting, and I would love to hear any stories from your side as well. But for now, yeah, I'm happy to answer any of your questions. Thank you.
We have questions, maybe just like shout them and you can repeat them for the easiest.
Yeah, very short question. So you're using now Grafana and Alloy, and like, would you say it was worth it compared to Datadog?
Mimir? You mean?
Please repeat the question.
Can you repeat the question?
I meant that you're now using two Grafana products instead of Datadog, right? With Alloy and Mimir.
Yeah,
was it worth it?
we use way more Grafana products, but yeah, in terms of cost savings, I would say yes. We save way more money now, but unfortunately, the developer experience is still. I think it's really hard to replicate the same experience. There are solutions like Signos. I don't know if you heard, like open source Datadog, but yeah, currently we can't provide the same experience that Datadog did. So yeah.
So while nice talks, by the way.
Thank you.
So when you have migrated from Datadog to your on-site hosted Prometheus setup, so while doing this calculation of the cost per metrics, per CPU, per team, right? So did you consider engineering time spent?
So the question is like, did we compare the costs?
Do you consider like engineering time
Engineer.
on
Yeah.
Yeah.
Yeah, I think that we considered engineering time, spent time, but I think we underestimated it, and I don't know. Maybe I think it's still. So we tried to kind of analyze it. I don't know, 1 year ago, and it was still less than Datadog for us.
Did you consider the Grafana Lab solutions?
I think so. Yeah.
To back that up, it would just be too cost prohibitive with Grafana Labs just for the pure amount of data that we have. And we needed a working solution before entering, say, sales negotiation. Sorry if anybody works for Grafana. But
Thank you.
Have you tried Grafana Agent?
Basically, Grafana Alloy is a new Grafana agent. So Grafana Agent, it's now like.
Okay, it's the new name for Grafana
Yeah.
Agent. I got it. Can Grafana Alloy then could be a replacement for Prometheus, or I understand it?
Yeah, this is a very good question. I forgot to mention it, like in my epilogue. So basically, Prometheus becomes for us just a collector. So we don't have rule evaluations. We don't store anything in it. So maybe we can use something else. So one of the first ideas, for example, can be using Prometheus agent, which is a lightweight version of Prometheus, without TSDB, without rule evaluations. It consumes way less resources. It just collects and writes remote writes to remote storage. But yeah, probably we will think about maybe using something else like Grafana Alloy, or maybe even OpenTelemetry with its target allocator thingy. So yeah, we will think about it.
One more question? Anyone? Okay, if there are no more questions, thank you again.
Yeah, thanks.